Welcome to this talk on A-level mathematics. At Haslingden High School, we currently use the OCR examination board and in particular the MEI specification. And MEI is an independent charity which is set up to promote mathematics in education and industry. Assessment takes place at the end of year 13 and consists of 3 exams. The first one is a pure maths and mechanics exam, and that is 2 hours long and consists of 100 marks. The second exam is a pure maths and statistics exam, which again lasts for 2 hours and is 100 marks. And the third exam is a pure maths and comprehension paper, which lasts for 2 hours and 75 marks. Whilst the mechanics and statistics might seem familiar, the comprehension paper consists of a written page of real-life application of mathematics, and your task will be to answer questions based upon that application. Why study A-level mathematics? Well, first of all, it will provide support to other subjects such as physics, maths, chemistry, as well as the statistical element will help in some social sciences subjects. It will also give you a greater depth and understanding of how mathematical ideas are connected and how we can use these ideas to model situations in the real world in a range of areas from finance to engineering. It also allows us to make sense of data and how to approach and actually be critical of the data and how it's presented to us. It will also prepare you for further study in a wide range of subjects or apprenticeships, whether you choose to go to university or not. It is a very solid foundation. And finally, for enjoyment. Why, and this is the reason why most people do study maths, the ability to solve problems using skills you have can provide a lot of satisfaction. A lot of the content at the beginning of year 12 is designed to build on higher tier GCSE studies, and in particular we look at the algebra aspect of higher tier, things like quadratic equations, simultaneous equations, using surds and indices, and we make sure that we are very proficient in using them because they provide a solid foundation for the rest of the course. We also consider coordinate geometry, so again things that you will have studied recently, things like intersections of lines and circles. We also look at polynomials, things like how we solve a polynomial using something called the factor theorem, and we use the remainder theorem. We also look at functions and how functions can be used to solve quadratics or solve cubic equations. And we also look at curve sketching as the best way to sketch a curve, how we translate curves. So a lot of these topics are things that you will have done previously. Some pure content is studied both in year 12 and year 13. We look at numerical methods, which is finding the most efficient way to solve an equation, whether that be using the quadratic formula, which most of you will be familiar with. We also look at trigonometry in much greater detail than at GCSE. We consider angles beyond 360 degrees. We look at solving trigonometrical equations. And then 2 brand new topics which you won't have studied at GCSE. Differentiation, where we look at gradients of curves and how to find what the gradient of a curve is rather than drawing a tangent. There is a more efficient way. And we look at integration, which is about finding the area underneath the curve. And sequences and series, again, you will have studied a little bit of this GCSE, but we're taking it into much more detail. And some content that is in just year 13 is advanced algebra, where we look at things like partial fractions and how we can use algebra to help us in other situations, in particular with our differentiation and integration. More trigonometry, again, more real life situations, how we can solve trig equations. Look at vectors, so again, something you might have studied a little bit at GCSE, but we look at them in much more detail. Further calculus, that means more further differentiation and integration. That really is quite a big chunk of year 13 pure content. And we look at exponentials and logarithms and their applications and how we can use them The mechanics aspect of the course is studied in Year 12 and in Year 13. And in mechanics, we look at using mathematics to model real-world situations. Using Newton's second law of motion, and in particular second law of motion, we consider force equals mass times acceleration and look at the effects that a force has upon the acceleration of an object. We also look at Subat equations, which you might have studied in Year 11, where we look at the initial speed, final speed, consider the time or the distance an object travels. We also look at forces in general and consider forces in equilibrium, where the forces will balance, look at objects on slopes and consider friction upon an object. We also look at moments, which is the turning effect a force has upon an object. And finally, projectiles, in which we look at how an object travels through the air. For example, a ball, we might consider what speed it sets off at, what angle it sets off at, how far the ball reaches, how high it gets. Just like in mechanics, statistics is studied both in Year 12 and in Year 13. We start by looking at sampling and different methods of choosing a sample from a population. So things like stratified sampling, you might have studied in Year 11, or systematic sampling. We also look at data presentation and the best way to represent information. Again, you might have done histograms, box plots. We also consider probability and look at how, in particular, conditional probability, where the probability of an event might depend upon what's happened previously. We also look at probability distributions, and we look at the binomial and the normal distribution. And finally, hypothesis testing, where we might wish to prove a statement is true or disprove a statement using statistical information. Looking beyond A-level and possibly even university, in the workplace, the ability to work systematically and logically to devise plans and execute projects is often highly valued, and Mathematics A-level provides a solid foundation in which you can demonstrate these skills. In an increasingly data-driven world, many companies value numerical competence in order to interpret graphs and data, and many graduate jobs, which are open to applicants from all degree backgrounds, require candidates to score well in a numerical skills or a numerical reasoning test. And studying A-level mathematics will give you the confidence and practice to succeed in these tests. And there is actually also significant evidence that if you take A-level maths, you will likely to earn more in your career. If you require any further information, then please don't hesitate to either speak to Mr. Young or email him on pyoung@haslingdenhigh.com or Mr. Sherrington, who is the head of maths, at psherrington@haslingdenhigh.com.